Hi there. For our last lesson of this chapter, the first thing, very important, is that instead of doing the questions at the end of this lesson, instead of doing this check your understanding, you'll notice where I X them out. I'd like you to do in the textbook instead page 320, questions 1 through 6 and number 10, and then C1 as well. So don't worry about the ones in this booklet, but use your textbook questions, okay? And I wrote the same things up in the top there as well. Okay, so our objective in this lesson is to be able to solve trig equations algebraically using trig identities. So it's an accumulation of a few of those things. So you should have your formula sheet. So the trig identities that we're talking about are all these ones here, starting on the left-hand column of your formula sheet, any one of those ones, and to solve these equations algebraically. So for the first example, solve the equation below algebraically if x is between 0 and 2 pi. So in the question, they say 3 cos x is equal to 2 times the secant of x minus 1 equals 0. Here's the first line. And then the second line is done for you already. They say, well, let's change that secant into 2 over the cos of x. So that first line's done for you. And that's what this step says here, right? It says use the identity to change secant into an express using cos. So now we've got all cos here. Now the problem is that this is hard to solve. So what we're going to do is we're going to use this next bubble here, this idea, to multiply both sides by cos of x. And you'll see what happens when we multiply both sides times the cos of x. So really I'm multiplying this side times the cos of x, and I'm multiplying this side times the cos of x. Okay. When I multiply the left-hand side, it is distributed across to each of these three terms. So 3 times the cos of x times the cos of x is going to be 3 times cos squared of x. And then when I multiply the middle term, I'm going to get minus 2. And then I get minus the cos of x is equal to, on the right hand side, it's still 0. Now I'm going to reorder this to 3 cos squared x minus cos of x minus 2 is equal to 0. This reminds me, I'm going to erase this a little bit, this reminds me of, let's say if I had 3a squared minus a minus 2. Right? It looks very similar. So what we're going to do is we're going to solve that. See if I can do my fancy little delete here. Okay, oh, almost. So if we try to solve this, we can get 3 times cos of x. And here another cos times x. So I need two numbers that multiply out to negative 2, and that after they get multiplied out, we get a minus 1. So I think if I put a minus 1 here, so 3 times negative 1 is minus 3, and if I say a plus 2 here, when this cos of x multiplies by this positive 2, I'll get minus 3 plus 2, so I get a minus 1. So my linear term works, my minus cos of x works. Okay, so there is my answer up until now. Now this should be a fairly familiar route now to the end. So we're going to say, well, one option here is that 3 times the cos of x plus 2 equals 0, or the other one here is cos of x minus 1 is equal to 0. So let's follow this left-hand path here first. So 3 times the cos of x is going to be equal to negative 2. Cos of x is equal to negative 2 over 3. It's not one of my special angles. It's not like a half or pi over any multiple of pi over 6 or pi over 4 or anything like that. So I don't know exactly what the answer is going to be. What I'm going to say is that my reference angle, cos of my reference angle, is going to be equal to positive 2 over 3. So we'll figure out for my first, for the first quadrant. So my reference angle will be the inverse cos of 2/3. So in other words, if I'm thinking here, this means that some angle x, so that the x value on the unit circle is minus 2/3. Okay, so my x value minus 2/3 would be about over here. So I'm looking at this spot here and this spot here. Okay, now my reference angle will be the place so that I have in the first quadrant here. Okay, so this will be, this amount of rotation will be my reference angle right there. So when I plug this into my calculator, I will get, oh, my big one here, the inverse cos of 2/3 is equal to, I just have to plug this in here. I get 0.8 over here, 0.84107. Got a bunch of decimals here. Now x is going to be negative in quadrant number 2, in quadrant number 3. So in my quadrant number 2 answer, it will be pi minus my reference angle. So there I get 2.3005, and in my quadrant 3 answer, I'll get pi plus my reference angle, and there I get 3.9827. Generally, 4 decimals is good to go. Okay, so those are my first 2 answers. Now looking at the right hand side, I get cos of x is equal to -1, so that means that the cos of x is equal to 1. Well, when do I get a cos which is equal to +1? I get it when x is equal to 0. And if I'm very careful and I look over here, notice it's not or equal to, so I cannot put 2 pi in there because of my the domain. So I have 3 answers here. I'll just try to state them clearly at the end. I get x equals 0, and then I get my 2.3005, and then my 3.9827. Oh, which is pretty close to what they have over here, but he rounded it off to 2 decimals. Okay. All right, so there's one example, and we only have one more example to do. How did I get up to example 3? What happened to example 1? Oh well, example 2 and then example 3. Okay. Here it says solve this equation algebraically. Sine of 2x plus cos of x is equal to 0. Maybe if I get something like 190, it'll look better. Still looks kind of funny. All right, the first one says sine of 2x. I'm going to replace the sine of 2x using an identity. Now there only is one for sine of 2x. Sine of 2x is this one right over here. So it's 2 times the sine times the cos. So I'm going to go over here. I'll say 2 times sine x times the cos of x plus the cos of x is equal to 0. Now I want to factor this. He's a little cheeky here with his comments. It says now you can use factoring. Can you say greatest common factor? So the greatest common factor of those 2 terms, what do they have in common, is this cos of x. So I will factor out this greatest common factor of cos of x. So I get 2 times the sine of x plus 1. Okay, so we could test it out. If I was to multiply this out, it would get back to my previous line. Okay, now that we're factored, I can say the cos of x is equal to 0, or 2 times the sine of x plus 1 is equal to 0. So again, when is the cos of x equal to 0? I've got to be very careful because again, it does not include 2 pi, but it does include 0. So for this part here, I'm going to say x is equal to 0. Because if you look again, if you look at the unit circle, when is my x value? Oh, wait a minute, it's different. Before it was 1. When is my x value equal to 0? Oh, it's up there and down there. So my 2 answers, this one was wrong, would be my pi over 2 and my 3 pi over 2. Okay, 2 sine of x plus 1 is equal to 0. So I would say here, the 2 sine of x is equal to -1. So sine of x is equal to -1 over 2. So the sine of my reference angle will be equal to positive 1/2. Thinking about when is the y value equal to 1/2. Here's it's at pi over 6. So xr is going to be equal to pi over 6. But when is it negative? It's going to be negative in quadrant number 3 and quadrant number 4. So in quadrant number 3, my answer will be pi plus xr. So pi plus pi over 6 is 7 pi over 6. Right, so just for those of you viewing at home, here is my 7 pi over 6 in quadrant number 3. And then this quadrant number 4 value will be equal to 2 pi minus xr, which would be equal to 11 pi over 6. That's that 11 pi over 6. Okay, so if I state all my answers then, so x can be equal to, so if we do an order from smallest to largest, I guess we would get pi over 2. Oh, let me just pause for a second. They're better, pi over 2. And then I think my next one would be 3 pi over 2. And then it would be 7 pi over 6. And then 11 pi over 6. So it would be these two answers and these two answers. So there's my answer. Okay, so again, one more reminder. Oh, look at that. Here's my answers right there. Try the textbook questions out. And we do have a quiz coming up. So I would say for the quiz, one is I'll be giving you a review to look over. And the other thing is the chapter 6 from provincial exam. Those would be great places to look to prepare for your quiz after you finish these questions. And we'll see you in class.